Hey everyone, hello and welcome to today's webinar on how to mitigate signal loss in indoor drone missions. Today we're going to cover theory and practice of radio signal propagation. So if you've ever run into a situation where your signal starts fading and you're wondering what you can do to address it, we're going to be thoroughly diving into that topic today. So first, I just want to thank everyone for joining us. This is in some ways a very specific and niche topic, but it's also a really important topic. As you know, if you've flown a drone or even thought about flying a drone, your signal really determines the range in which you can fly. We do want to say here at the beginning of the webinar that we know that people are suffering throughout the world. You know, the pandemic has been going on for a very long time now, but it doesn't change the fact that it's impacting our daily lives, and not always, well, not for the better, right? There's a reason for some of us that we're on a webinar instead of sitting face to face. So we just think that's important to say. We're grateful for all the important people who are working during the pandemic, and just want to take a moment to acknowledge that. So today we'll be hearing from Gregory Spearlet, a professional services engineer here at Flyability. We'll also be hearing from Mike Van Overmeer, Midwest Territory Manager at MFE Rentals. I'm your host. My name is Zach Dukowitz. I'm the Content Marketing Manager at Flyability. A few just housekeeping items. If you have any questions at any point during the webinar, please feel free to use the question pane. We really encourage you to ask questions throughout. If we can't answer them live, which often we won't be able to, we will be curating your questions and covering them in a Q&A at the end. And of course, if you have questions that for some reason don't get addressed during today's webinar, we'll have everyone's emails up at the very end of the webinar so that you can reach out via email. We certainly don't see this as the end of a conversation, it's the beginning of a conversation. So please don't be shy. If you have lingering, uncertainties about the topic after the webinar, please do reach out. Another question that we get often is whether this webinar will be available as a recording afterward. The answer is yes. We will be posting a recording. It takes about 12 to 24 hours to process. So as soon as we have the recording, we'll share it on the Flyability website, and we'll be sending you an email with that recording. And one last thing to cover is just the agenda for today so that you can know what you're in for. So we're going to take about 5 minutes for the introduction. That's what we're doing right now. And then Greg will present. He'll be talking about radio signal propagation and technical checks for 15 minutes. And then we'll hear from Mike on using reconnaissance flights to mitigate signal loss. And then we'll do a panel discussion and Q&A for the last 25 minutes of the webinar. So I'm really excited to introduce Greg. Greg Spearlet will be presenting on radio signal propagation and technical checks. His title at Flyability is Professional Services Engineer. He's both a professional pilot and a trainer of flyability products for our customers. He's had numerous experiences leading trainings on the Helios 1 and the Helios 2, and also performing demonstration inspections throughout the world. Greg's in charge of creating our technical documentation and training materials for Flyability. Today he's going to be sharing some of the insights he usually conveys to customers when he's doing trainings on how to deal with signal loss. So yeah, without further ado, I'm excited to hand things over to Greg.
Thank you, Zach. Hello, everybody. Today I'll be talking about two aspects, basically signal propagation, the theory part of that, and then the technical checks that you can conduct on your equipment to hopefully avoid damaged caused signal loss. So first of all, we'll talk about the propagation part. If you could move forward the next slide, please. One more. All right. So basically, the transmission systems that you find on most drones are designed for line of sight operation. typically you won't have a lot of obstacles between you and your drone in an outdoor environment. However, with Helios 2, you often find yourself flying in confined spaces. You don't necessarily want to be inside that confined space with it. So we kind of have to make do with the radio system that we have. First of all, when we talk about line of sight, it means that there are no obstacles between you and the drone, right? So that means that mostly there will be transparent materials such as air between you and the drone. And in an indoor environment, actually some other transparent materials that might be between your drone would be glass fiber, wood, plastics, and glass. So as far as the radio signal is concerned, up to a certain thickness, these are transparent materials and the signal will just go through them. Now, the next slide will discuss the different class of materials, which are the reflective materials, such as metals. Now, most metals will fall into this category, which is good because we really like building stuff out of steel in an industrial setting. And the advantage of that is that as soon as you get the signal inside of the confined space, it'll just bounce around and distribute itself quite nicely inside. So as soon as you have a manhole open, which you would obviously to get the drone in, the signal is going to be able to enter that confined space. And if it's made out of metal or something reflective, it's going to bounce around and you'll have no problem at all having connectivity inside of it. Unfortunately, we also like to build stuff out of concrete, which is shown in the next slide, which is an absorbing material. So what happens then if you have exactly the same environment built out of concrete, it's not going to bounce around, it's going to get absorbed into those walls. And as soon as you go around the corner with the drone, you stand a very good chance of losing connection. So we have a solution for that. Apart from crawling into the confined space yourself or sticking your remote control in there, you can attach a range extender to your remote control, which is shown in the next slide. This is basically a signal booster on top of a cable at the end of the cable. So you can so the booster actually kind of makes up for the losses you have in the cable. So the signal that comes out in the end is not necessarily stronger than it would when you're just holding the remote control, but it allows you to place the eventual antennas in a more convenient place, which means you can actually reach those areas around the bend by, for example, lowering this into a sewer. So the next slide shows the real-life example of a boiler. Now, these boilers tend to have massive cyclones, which are covered in refractory, which is a kind of concrete. It's absorbing, but the boiler itself is made out of a steel alloy. So because of this combination, you tend to have these hot spots and dead spots. And the signal bounces around inside the main boiler quite well, but then as soon as you go into the concrete part of the cyclone, it kind of dies off pretty quickly as it gets absorbed into these refractory areas. So this is represented by this schematic on the right. So you can actually have this little bubble of connectivity in the cyclone that you can use to have a peek inside. But if you go further and further inside it, you stand a bigger and bigger chance of losing connectivity. And this actually happens as well if you're in an extremely large all metal construction, that eventually the way the signal bounces around is kind of hard to predict. And it's very much like if you've ever been in a hotel room which has slightly suboptimal Wi-Fi connectivity, just by scooting around your computer a bit, you can find a sweet spot where we have better connection. And it's very much like this. You'll see the drone moving in and out of this spot, and even how you hold your remote control, obviously. If you're facing with your back in front to the manhole and holding the remote in front of you, a lot less of that signal is going to make its way into the confined space. So the way you hold your remote is also quite important in how these reflections go around. The next slide shows that obviously the signal only likes to go around bends if there's something to reflect off of. And the first example on the left there would be a sewer where you have one shaft going into a tunnel. Obviously the range extender in a very nice place there, but as soon as you fly to the right and try to make it up the next manhole, you will lose connection because you lose line of sight with the range extender. And this will happen quite quickly because it's a damp concrete environment. There's very little chance of something reflecting that signal back up into the next manhole. The example on the right is actually, for example, if you have a metal oil silo that you would like to inspect from the outside. If there's no way of getting the signal into that metal structure, then it's not going to get in there. It's not going to magically, go through the first layer and then start reflecting off the second one. And if there's only open sky above it, then it's not going to reflect down into it either. And this is actually a real life example where we've seen a drone being lost in this, because a pilot thought he could just fly into the silo, and obviously as soon as you go under the lip, it's going to lose connection, and it actually ended up crashing in a sump there. So that's something to remember. Even if you're in a reflective environment, unless you have a way to get the signal in there, it's not a guarantee for good connectivity. To make things worse, actually, in the next slide we show the effects of having a digital transmission system, and the properties of this digital system is such that there is a very sharp drop-off of. If you could switch to the next slide, please, Zach. Thank you. So there's a very sharp drop-off in terms of image quality. So on the bottom axis, so the x-axis shows the signal strength, which will decay, in the best of cases, it will decay linearly. In the worst of cases, it will also drop off quite quickly as you fly behind a corner or the signal gets blocked by an obstacle. But on top of that, the picture quality decays very quickly as soon as you reach a certain weak signal strength. And this is called the digital cliff. And you'll notice this quite, if you ever tried flying at the edge of the signal quality, a very short increase in distance is going to cause a very significant decay in signal in image quality that you get. So signal loss can actually occur over a very short distance. The next slide shows some environmental impact. So I'm going through all the negative things that can go wrong here, which are basically things to watch out for and avoid if you can. So try to figure out if any other equipment is transmitting in your frequency range. Now this is the 2.4 gigahertz frequency range. And the reason drones use this is because it's kind of a free-for-all frequency. Any commercial or consumer electronics can use this without special licenses. So that means a lot of stuff out there actually transmits on this band. The stuff you find in an office environment would be the Wi-Fi. It's the same frequency Wi-Fi operates on. So any phone, computer will be competing with the signal from the drone. In industrial environments, you will see these things called radar level gauges, which are actually operating inside some vessels to measure the level of the whatever liquid or material is stored inside. And we've had some losses that we thought could only be blamed by this kind of equipment. A very sudden loss of signal in an environment where you would otherwise expect extremely good connectivity. So if possible, if you think that these might be operational, ask them to turn them off, because usually they're always on, unless you specifically ask for the site manager to turn these off. The top right shows other drones. Obviously, if you fly 2 or 3 drones at the same time, now this is a cave where we have 4 drones flying at the same time. You wouldn't probably typically do this on a job, but we noticed a serious signal degradation, even though we were at quite close ranges in this environment. And then on the bottom, you see equipment that doesn't really use the same frequency, but that transmits on such a high power level that it might actually spill over and still cause issues. So microwave ovens are on a slightly different frequency band, but if you turn them off, you can still, if you turn them on, you can still notice a signal noise level increase. The other example is shipping radar. Again, these are transmitting on kilowatt levels on a 3 gigahertz band, slightly higher frequency, but still transmitting at such power that they can still cause issues. So the next slide shows kind of what to look out for. These are the early warnings of signal loss, and Mike is going to go into this a bit more. But basically, despite all of the scary stuff I just told you about how sudden this can be, there are definitely indicators that you can watch out for, and some steps to take, like to mitigate losing the entire drone. On the top left of this animation, you can see these signal indicators. So 5 bars obviously is excellent quality reception, and 0 bars would mean you lose the video signal and eventually control of the drone. Between 5 bars and 0 bars, you have a whole bunch of symptoms that come into play. So you see this line scan effect on the video, pixelated artifact, the image freezing, and eventually you lose the image. But even without image, you still are in control of the drone, because the control signal requires a lot less bandwidth to get through. So even if you see nothing, you are still in control of the drone until you see that black screen, and that means it's pretty much over. So between losing, between the onset of the first signal loss effects and losing the drone, you can still control the drone and get it out of there. So the first reflex would be to undo your last input. If you're going forward, go backward, and that'll bring you hopefully to a spot where you're back in control and where you have better reception. And I think Mike is going to share some tips on that as well, on some other things you can do to help regain signal in these situations. That's pretty much it for the environment and radio propagation theory. I'd like to spend some time as well, since I'm closely involved with customer support and some of the technical issues that people have on the field. I'd like to go through some technical checks that you can perform before critical missions to make sure that your equipment is in order, just to avoid signal loss due to malfunctioning equipment. So obviously, first check would be to check your antennas. That's the first thing you do. And this slide actually shows the transmitter antenna. You can do the same thing on the drone. On Alias 2, the antennas are the two little paddles sticking up on the rear motors. On Alias 1, they're like the little rabbit ears that are on top of the drone. So make sure these are free of damage, that the cables aren't kinked, as you would see it here. We see a lot of these drones, we see a lot of these transmitters have broken antennas, and that can mean that either something yanked them off, so there could actually be cable damage either inside of the controller or inside of the antenna. So that this is kind of a giveaway that something's wrong. If you look at the next slide, that would be the range extender compatible transmitter. And these also have antennas that can break. Typically, these plastic joints are the first thing to go, and then basically the strain relief on the antenna is gone, and any kind of pulling force on the antenna itself is going to transmit into the antenna, which might become desoldered, and well, leads to signal loss on that part of the transmitter. Now, you do have two antennas, which are two completely different, two separate redundant systems. So even with one broken antenna, you'll still have adequate connectivity to the drone. The other thing, if you look to the next slide, of these range extender transmitters, is that they are modified to have an SMA connector, which allows you to unscrew the antennas and screw the range extender onto them. One issue if you screw the antennas on too tight, or the range extender cables, is you will start turning the entire SMA connector, and eventually, if you look at the right hand image, this will start untwisting the cable internally. So if you overdo that, it'll eventually lead to this kind of internal hardware failures. So make sure that there's no, you don't tighten the antennas too much, or that you don't cause the entire connector to rotate as you're tightening them. The next slide shows a range extender. So plenty of cables going in and out of modules. So you've got the image on the left here showing from left to right, it's showing the transmitter module, then there's a coil of cable, then there is the battery module, and then there's a smaller coil of cable, and then you've got the SMA connectors that connect onto the remote. Ideally, you would check the entire cable for kinks. You don't know, if you're in a company that shares this equipment, maybe someone dropped it, maybe someone slammed a hatch onto the cable, and it could have caused damage. So inspect these carefully, especially the SMA connectors that plug into the remote. If you're careless and forget that you're actually tethered to something while you're holding the remote, you might actually, absentmindedly walk off and then yank the cables as you're doing so. So that's definitely, if possible, incorporate some strain relief into your setup, as we did here with the battery module. You can see it's tie wrapped to the cable, just to avoid the cables pulling directly of whatever forces that might be on there. And the next slide, obviously the range extender is battery powered. Don't forget to plug in the battery. That's extremely silly way of losing a drone. I've been there. So make sure the battery's fully charged and connected before you take off. And one really nasty aspect of it is that there's always some radiation, some radio signal leaking out of the remote. So you'll be able to arm the drone even if the range extender is not connected or powered. But you'll find out as soon as you fly away a couple of meters, you'll lose connection. So that's something to be very, very careful about. The next slide shows some of the cockpit menus. So if you go into the cockpit app and then tap on a menu, there's a radio tab, and that shows you the signal noise level on the bottom. It also shows you the actual transmission power that's received by both the drone and the ground station, measured in dBm, so it's decibel milliwatts, I believe. With the drone next to the transmitter, it should be around -20 dBm. If there's an asymmetry in this value, so one of them is at -20, one of them is at -30 or -40, that indicates hardware failure actually in the transmitter or in your range extender or somewhere in the line between the drone and the controller. So what we're looking at here are these values here: LB1 right, LB2 left, and then RC1 right, RC2 left. So these are the dBm values. Should be around -20. If there's any asymmetry in these values, then dig deeper and see if you can find some kind of a hardware error. The next slide shows the noise floor, and these are actually microwaves in the background. And you'll see when we switch to the next slide, the microwaves will be turned on, and there's a significant increase in the noise floor. So you can use this menu also to check if there's any equipment that might cause you problems. If all the bars are orange, then take into account that your range will be significantly lowered. And that's pretty much it for the technical checks. We'll go into some flight examples. I don't know how we're doing with time, if we've got time for these.
Yeah, we've got a few minutes, Greg. That's no problem.
All right, great. So the first example I'd like to share would be metal environment. So this is a penstock distributor, and basically this is the metal piping that brings high pressure water from a dam to turbines.
Hey, Greg, just a reminder that you're automatically muted when the video starts.
Right, got it. Yeah, so thanks for reminding. So you can see on the top left that there's some transmission bug seems to be going on. So I'm flying close to the range extender, and by the way, these are the old school range extender where the battery is still inside of the module. Checking if the battery is connected, also going to the menu to see if there's any transmission issue. Once I'm happy with the values, carefully pressing on into the penstock, and that it turned out to be a glitch. So nothing to worry about. We keep on flying, and this kind of shows that once you're in a metal environment, even behind several 90-degree bends, the signal stays like impeccable. It's really incredible. Again, we're seeing some metal piping with paint on it, and it's also wet, so it's been recently drained. So all the walls are actually wet, and that doesn't seem to affect the propagation. There's plenty of metal to bounce that signal around. These are actually the injectors that go around the turbine and inject the water onto the turbine wheel. So this is basically an environment where you're limited by battery flight time. There's actually, we did another flight going up, and we actually think we calculated we went 300 meters into the penstock. So there's absolutely no transmission issue in this kind of environment. If you switch back to the slide, actually the first slide of this chapter shows a top-down view that was generated during photogrammetry. So that'll just give you some of the scale and geometry that we just flew into. And actually the next slide, actually 2 slides further, will show the next example, which is a sewer. And this kind of shows how even in a concrete environment, if it's pretty much a straight line, you can fly quite far. So this is 110 meters. We started in the bottom left. There's a little bit of a waterfall in the middle, so we'll point that out in the flight because it's like a significant event that I'd like to comment on as well. And finally, the signal becomes critical as we go around that bend, and that's a 90-degree bend. And soon after it, the signal starts to break up, and the pilot says, that's it, going home. So if you could start the video.
Hey, Greg, you're muted again.
Yep. Sorry about that. So this is a sewer. Basically, it's a straight line. Like the issue is you don't want to land in the water for various reasons. Obviously, if the water is a bit deeper than this, you might actually lose the drone. And this is a waterfall, so you want to fly around that because it's not a waterfall. It's like water and other stuff falling down. And right here is when the signal suddenly has a weird glitch. And you can see the last thing the pilot does is slam the throttle up and just cramming the drone onto the ceiling. And this is really quick thinking because that kind of prevents the drone from going into auto land, which is the typical fail-safe. It sort of like hovers around against the ceiling for a while, and that probably saved the drone. So just using that last second of control input to basically either fly the drone back towards you. In this case, that was not an option because it would have flown straight into that waterfall, or at least getting it as far away from harm as possible. And we just came around the bend, and you can see the signal strength in the top left kind of going down to 2 or 3 bars, and that's together with the battery starting to reach bingo there. Pilot says, call it a day, we'll head back. Getting some nice POIs of these outlets on the way.
And Greg, I
So
think
the reason that,
sorry. I think we're going to need to move on to Mike's presentation just for the sake of time. Apologies for interrupting.
yep, I'd just like to point out that probably what we figured out, most likely what caused this signal glitch is the waterfall absorbing the radio signal, because water is an signal absorbing material. So like a curtain of water would act like a sponge that just sucks up your radio signal. But all right, that's the end of the flight, and guess Mike can take it from here.
Okay, great. Let me, here we go. And Mike, you can, yeah, there you go. Perfect. Thanks so much, Greg.
Morning, everybody.
Yeah, morning. So I'm really excited to introduce Mike Van Overmeer. I've been working with Mike for a while now. He's the Midwest Territory Manager at MFE Rentals. He has an extensive background in inspections, and he holds multiple level 2 NDT or non-destructive testing inspector certifications. He's been working at MFE Rentals for about 5 years, using his inspection expertise to help professionals leverage robotic solutions, including drones, to improve their inspection workflows. Mike regularly leads trainings in the LEOS 2 and other remote visual inspection solutions. Today, he'll be walking everyone through the materials he usually shares when he's training people in how to mitigate signal loss while flying the LEOS 2 beyond visual line of sight for indoor inspection. So I'm really excited to hand things off to you, Mike. Go ahead and take it.
No, much appreciate the introduction, Zach. And Gregory, a lot of good information that you put forth. Appreciate the graphics, appreciate all of the footage. A lot of that is very useful info, especially the technical checks, and really can't overemphasize on a lot of that material, guys. That is one of the big things to be checking. So as Gregory had kind of explained and as Zach had introduced, the idea here is that I want to be covering some of the reconnaissance flights and basically what you guys should be looking to use these for. Zach, if you would, let's go ahead and advance on to the next one following that, sorry. There we go. So a lot of things happen during a recon flight. There are several things that flyability and we try to teach for this. Some of them being familiarizing yourself with the confined space that you guys are actually flying in, looking for and actually recognizing the hazards in that environment. And a hazard is deemed as anything that can fit inside of the cage of the drone. During it, you also want to be locating the area to inspect. Probably the second most important is remembering your way out of the asset, and that comes into play a little bit later, but is a very big point. Two of the biggest and most often forgotten about things is the idea of testing your battery life during a recon flight and testing your signal reliability during a recon flight. The further you tend to go, the less your signal is going to reach. So the idea is basically during a recon flight, you want to push the limits of the drone, of the battery, of the signal reliability, so that you know where your furthest to go point is, or your cannot pass that point is. If we would, let's go on to the next slide here. This is going to kind of explain the idea of where should you be positioning yourself physically. So from a piloting standpoint, when we are flying inside of an open building, such as the one that I happen to be in here, a lot of where we position ourselves is not going to be as big a concern. When we do look to fly inside of something like an asset, like I have here to my left, or down into a sewer or into another vessel otherwise, it's very important where we physically place ourselves, place the controller, and have that signal going into the asset itself. So, Zach, if you would, on the next slide. So the most common mistake that we end up finding like this is that a pilot would stand as close to the, we'll call it the ledge or that cliff area that they can get to, so that they are as close to the drone the entire time as possible. The big problem with this is, and as we saw in some of the videos there, once you start to experience the signal loss or complete loss of that signal, there's really nothing that you can do. So what can you physically do once you experience signal loss from this type of standpoint? Almost nothing. The idea of trying to pin the drone to the top surface is a fantastic one. And like you said, it was a last second thought, but it probably did end up saving the drone. So on the next slide here, it is going to explain that as basically you stand too close to it and it gets away from you, there's not a lot you can do to bring it back. The next slide is The idea is that you want to leave yourself a buffer zone. So your feet as a pilot are not sitting in cement. And one of the biggest things that we can think to do is in the moment of losing signal, you may not know what your orientation is. A good pilot always maintains what their orientation is inside of an asset in that, but there are a lot of different factors going on, a lot of different thoughts going on inside of your head at the same time that you're flying. So one of the biggest things we insist is that you leave a buffer zone between where you can physically get to, that physical barrier that you see in front of you there. Call it a cliff, call it a wall, whatever, but we as the pilot cannot get past that point. It can be a manhole, anything like that. So as the drone, Zach, if you will go ahead and animate, as the drone goes away from you, you move that distance forward, you have a pretty darn decent chance of being able to retain the drone or get that signal strength back and then make your moves back from there. And then now on our next slide here, this is just kind of an overview of what our actual training facility looks like here, or at least one of our training facilities here. But part of the idea is that what we try to do to make an example of signal loss is simply closing our hatch door, making our pilots stand further away from the actual vessel itself so that most of the signal does not get inside of there. We want to see what they do and kind of how they overcome with that, and then we use that as a teaching moment to explain these exact principles that we're all going through now. So on to the next slide here. What we should be seeing is that our pilot would be standing about 3 to 5 foot away from where that manway entrance is. And this is something that we do advise for those that are out in the field doing this inside of other vessels as well. The concept stays very much the same. So if you are not physically in front of the manhole, like inches in front of it, you would want to be a few feet back so that if you did start to experience that signal loss, you have the opportunity to move forward pretty quickly to regain that signal loss. So on our next slide here, we're going to be seeing some of the tools that we can use to help us boost that signal. And even though Gregory had kind of hinted at this, the idea of it being the flyability range extender. So the next slide shows the range extender here, and the idea of it being it's an omnidirectional antenna. So once it's inside of the asset, it is basically blasting signal all over inside of there. You can stand up to 20 meters away from this, or about 60 feet away from where you actually want your signal being broadcast from. The really nice feature of this is that it's backwards compatible between Helios 1 and Helios 2. So for those of you that were early adopters years ago, this is very much a system you can use with that. And for those of you that are just getting on board with this type of platform, this is one of those essential pieces that as we get more time in the field and as our clients get more time using this inside of different assets and equipment, this is proving to be one of those vital pieces of equipment. So, okay, Zach, let's move on to the next here. The idea is you have got to pay very close attention to the actual asset that you're flying in or the area that you're flying in. A lot of the issues that you will run into, aside from your technical glitches and things like that, is your signal absorption into concrete, water, dirt, things of that nature. But as Gregory had mentioned, the idea is that signal propagates off of steel or metal and it bounces around inside of that area. So inside of something like this warehouse here where I'm doing crane runways, something like this, I probably wouldn't need to utilize a range extender for because I have plenty of metal around me for that signal to just kind of propagate and bounce around. If you do notice there is insulation panels all over, be it the sides and the top of that, that is possible to absorb some of that signal. But again, with the amount of steel that's in there, shouldn't be a problem. When it comes to the image on the left there being a stack is a great use for a range extender. It's one of the go-tos for that type of thing because many of them are either refractory lined on the inside or you simply can't get your controller in there to point the antennas up to really broadcast that signal as high as you'd like to go. So if you were trying to utilize a range extender for that, the idea being that you have to get it inside of the asset without physically putting your body into the asset as well. That would break what's called the confined space law. So luckily we have some tools in place here for actually trying to get this stuff in place. And I believe the next slide is going to show that here. Oop, there we go. Not that one, Zach, the following one with the attachments there. There we go. So For those of you that don't know it, and for many this was a new feature, but on the bottom of the range extender, there is a Phillips head screw that once removed is going to give you a 1/4-20 mount or a tripod mount. And one of the biggest things that we can insist to you is to utilize that to your benefit. In order to not break confined space law, we can stick a pole, we can stick a tripod, we can stick a net, anything like that inside of an asset, as long as our physical body does not break that plane, that invisible line. So we would utilize things like this, whether it be a pole mount attachment, something that can thread into the bottom of it, an actual tripod itself, another tripod mount that we can mount to different types of ROVs or vehicles to kind of carry that signal where we need to get it to if we physically cannot get ourselves over to that point. So the next slide here is going to kind of give you a illustration of one of our clients had an issue with this type of vessel, and they were worried about trying to get signal propagation into the 40-foot section that's on the right-hand side there. Now, from our standpoint of this is one of the more complex or hard things to do for this type of platform. So this took some real ingenuity in it. And the idea of it was to basically be able to broadcast signal down into that 40-foot section there, but doing it reliably. So from our standpoint, the pilot could not go into the stack. They could not go into the other section on the right-hand side there. The best they could do was to be situated on a platform on the upper side of this stack. And it was physically impossible for them to do the idea of lifting the controller up over. Even if you could, you wouldn't be able to see what was on the screen. So the next slide here is going to show kind of how we achieved what we were trying to achieve by basically launching the flyability range extender into the vessel and positioning it against the inside of the wall at a certain angle so that it would broadcast the signal into that 20-inch opening that is there for the drone to fly through. So once we managed to get beyond that point, the idea was explaining that once inside of there, there is not going to be a bunch of signal. So you are going to be flying in a very, very low range of signal. So once they made it inside, that was about the furthest distance that they made it in before coming back out with the video footage that they had. If you look on this graphic along the edges on the outside of the radio signal here, I left that blank because this is a refractory lined vessel. So if there was any way to make this even harder, it's to introduce a sound or a radio absorbing material inside of there. And that's exactly what we had for this. So this was, again, one of the tougher instances that we've had to run into for this, but a little bit of thinking, a little bit of discussion, that's how we can come up with some creative solutions for doing this. And the one other method that could have been used for this, still with a range extender, would have been to attach it to a pole and try to basically lean it across all the way from that top lip into the 20-inch opening. It just doesn't leave a lot of room to work with after the fact. So, Zach, if we could, let's go on to the next one here. Oh, I think the one prior to the attachments there was the video slide.
Oh, I see. Yeah, I can go ahead and pull the video up. Does that sound good?
Yeah, absolutely.
Okay, great. Here we go. And just a reminder again that it will automatically mute you once it starts playing.
Appreciate that.
Hey, Mike, you're muted.
My bad, I didn't check that there. There we go.
Sorry about
that.
So
what we can see inside of this here is this entire facility is completely surrounded or encompassed with cement. There's little bits of steel in it, but mostly cement. And as you saw right out of the gate there was already, and again, a little bit of signal interruption. Now, the first thing you are always going to notice on this is going to be video lossage or video cutting out just to this extent. If you run into this right out of the gate, that is immediately in my head an instance where the range extender comes into play, or simply positioning yourself in a different spot comes into play, and using this as a recon flight to determine where that best point sits. And as we see, the further in that we will get, we will continue to drop off in footage. There we go again. The one thing I can say I appreciate from this is that the pilot's moving very slow because they're testing their boundaries as they go through all of this. Each room that they make it into, you can see again further signal loss. And in your upper left-hand side here, if we're watching our controller and our camera signal quality, we will be seeing very soon this start to drop off. We may have seen 1 bar in the past, but right here, especially beyond this little hallway entrance, this is where we lose it almost completely. You see 1 bar drop off, 2 bar drops off. Continue in, now we see 2 bars dropped. Now we do get a prompt actually telling us that we have a weak signal for those that don't catch the video transmission coming across. And just a little bit further and poof, we're gonna be there. Again, this is the pilot just pushing inches by inches, just trying to get that spot to find out what the furthest they can go. And we have formally lost all video quality there. Just a second, there we go. This is the worst moment in a pilot or for a pilot, is to have this happen to you. It's the not knowing what's going to happen, and it's not knowing what's going to happen to the drone. Luckily, the pilot here was able to get signal to come back even briefly. We lost it again. And as we'll see, the drone was landed on the ground there, and pilot probably moved a couple feet closer, again, leaving that buffer zone there to do so. That allows you to regain that signal strength and then be able to lift back up and bring yourself back to your home base, or at least get close enough to where you can go retrieve the drone. So again, the idea of this is understanding the area that you guys are flying in, understanding the materials around you, testing your drone, using your recon flights. This could be the first battery, second battery, fifth battery, it doesn't matter. The idea is to get yourself comfortable inside of there and knowing what the limits are for the craft and yourself. Okay, and Zach, that actually finishes for me. The rest of this video here is just kind of going back to the home base, but gets the point across it.
Okay, excellent. Thanks so very much, Mike, for your presentation. I really appreciate it. We're going to switch to the Q&A, so you can leave your camera on, and Greg, if you can pull your camera up as well and unmute yourself. Just a few quick things before we dive into the Q&A. I know we're a little behind on time. I do want to say we'll probably go a little over so that we make sure to answer the questions that we can. Before we dive into the Q&A, you'll see on the screen there's a list of past webinars we've done. So starting back in April, we started doing a lot of webinars. No surprise, right? Everyone was stuck at home. We figured it would be a good way to continue to share information. And the first series of webinars we did were keynote talks that were supposed to have been done at our grand opening at our Denver office, our US office. Of course, we couldn't do it in person, so we converted them into a webinar series. I just wanted everyone to be aware of these. The recordings are all on our website on the events and webinars page. I'm not going to take the time to read through all of them, but we've been doing a lot of webinars. We have more webinars coming up. We have a webinar on how to conduct missions in high-risk environments that will feature case studies and use cases coming up on November 5th, which is a Thursday, same time as today. We'd love to have you there. So go ahead and take a look on that page if you have any interest on any of these topics. All that being said, one last note before we dive into the Q&A. If you are located in the US and you have an interest in purchasing a Flyability drone, Mike is probably your best contact. You can see his email up here on the screen. If you have training needs, Greg is your best contact here at Flyability. And if you have an interest in purchasing a Flyability drone and you live somewhere outside of the US, Junio, whose email is up here at the bottom of the screen, he's your best contact here at Flyability. So all that being said, let's go ahead and dive into questions. Okay, so Mike and Greg, I'm just going to ask these questions. You guys can kind of field them as you want. We can go back and forth. I think that works. So Greg, I'll start with you. We had a question from Stefan who was asking, is it possible to place the range extender on another place of the controller, or must it be connected directly to the controller?
The range extender plugs into the controller directly. So it has these attachable antennas. You take off the antennas and you screw on the range extender, and it basically, the range extender becomes the new antenna. So I guess, yes, you would have to always connect the range extender to the remote.
Got it. Thank you. And Mike, I'll ask you this one question from Vincent in the audience, who's asking, with a range extender, is the signal only emitted from the booster, or is the signal also emitting from the cables?
The signal is coming from the booster. So the idea is that some of the signal may be leaking out from the sheathing around the cables themselves or anything like that. But I would say about 98, 99% of the signal is coming through the range extender itself.
Got it. Perfect. Thank you. Another question, Greg, I'll go back to you. How would you assess the reflectivity of a PE lined pipeline?
Depends on the thickness of the lining. So I guess PE would be slightly absorbing slash transparent. So if there's steel behind the PE and it's not too thick, I would say it still counts as reflective, but you probably wouldn't expect the same range as in a bare steel environment.
Thanks, Greg.
That makes sense.
Yeah, we have another environmental question, and Mike, I'll take it to you, but Greg, hop in if you know the answer too. Eric's asking if we know how vitrified clay pipe, called VCP, might function in reflectivity of signal. Is it similar to concrete, more metallic, or do you guys have any experience with that?
That's a fantastic question. Ultimately, the way I would look at it is that clay is going to act like soil, or yes, cement. Do I think it's possible to get some reflectivity off of it? Maybe. But do I think it's going to be outweighed by the denseness of the material and the sound absorption? Yes. So in my opinion, I would think it's going to absorb the material much more than it's ever going to extend it or reflect it.
Got it. Thanks, Mike. We have Jeffrey asking, does the use of bigger antennas, bigger meaning the length, help when it comes to extending signal?
I
Greg,
guess
that could be for you, yeah.
So the antennas that are on the range extender by default are quarter wavelength width antennas. So they are omnidirectional antennas who are already, and these are already tuned to the frequency used. So putting a bigger one on there will not necessarily improve range. What you could do, and this is not something that we sell, is put directional patch antenna on instead of like little whip antennas that come with the remote. That would be possible. I've seen this being done with outdoor drones, where having a directional antenna makes sense if you're going far out and you can sort of point it at the drone as you're flying. I have never tried these, and I have no idea how they would work in confined spaces where you would have reflections. So I guess short answer is longer antennas would not necessarily work, but you could put different antennas on them. But I have no experience with those.
Got it. Thanks so much, Greg. Do you have anything to add, Mike, on using bigger antennas?
Not particularly, no. I mean, the setup that you got, that Flyability has put together for this is honestly fantastic. The amount of uses that we see for the range extender in that and where it comes into play, I don't necessarily know that trying to beef up the antennas or trying to do anything else with it is going to outperform what's already there, if that makes sense.
Sure. Yeah, that does. Question. So I actually misspoke. I said for all training needs, reach out to Greg, but MFE also provides training if you're in the US. And given that you may not want to fly to Switzerland, MFE may be a better option. So I actually wanted to cover real quick what kind of training, because we're seeing questions, people are asking, what kind of training is out there in general, not just for signal loss. And I'm wondering, Greg, could you just briefly cover the types of training that we offer, and then we'll kick it over to Mike to also cover the types of training that MFE Rentals offers. So Greg, if you could take it.
So the training we offer would be the introductory training, which comes with the drone. If you buy a drone, you are entitled to take that training. It's included in the purchase price. Additionally, we have the what we call the advanced inspection methodologies training, which is an additional training which we can do on site in Switzerland. And then we have specialized trainings. Right now, this is the photogrammetry training, which we offer either on site in Switzerland. And because it's a classroom training, we are also offering this one online as a webinar training, and moving to create a online video course as well for this.
Great, thanks so much. Greg and Mike, if you could speak briefly to the training that you guys offer at MFE Rentals.
Sure thing. So across the country or across the US here, we've got 12 US offices. All of them are capable of hosting the Elios 1 and Elios 2 introductory training. We out of Chicago, our Houston office, soon to be our Long Beach office, and our Edmonton office up in Canada will be offering the specialized training for Elios 1 as well as the AIM training for Elios 2. And soon to be, we will be offering the photogrammetry training for Flyability as well.
Excellent. Thanks so much, Mike. And again, obviously, Greg and Mike's emails are up there. If you guys have questions, please do feel free to reach out to either of them. Question from Maureen in the audience. Maureen's wondering if heavy dust has an impact on the signal.
So that is a really good question. So I can honestly say that we have had these crafts into some of the nastiest, dirtiest, dustiest environments that quite frankly I've ever seen. Some of them even being steel mills. And what I have witnessed is that dust does not have nearly the impact on signal strength because it's usually surrounded by something such as metallic structure or something to that extent that kind of outweighs the dust that's there. Dust is going to act very much like what water is as far as absorbing that signal. But again, with the materials that are around it, and that signal has seemed to stay fairly consistent in those types of environments. So while I do think that's a great question, I think I just haven't ran into the situation where dust has killed the signal strength relative to what else is around it.
Sure. Yeah, that makes sense. Thanks, Mike. And so, Greg, question for you from the audience. When considering temperature conditions in which the range extender can be used, are there any other considerations that wouldn't impact the drone the same way? Basically, is the range extender more sensitive to temperature conditions than the drone? Or are there additional considerations with temperature when it comes to using a range extender?
I would guess it's if you can fly the drone there, you can use the range extender in the same environment. So I don't think it's not going to be the limiting factor, either with temperature or ingress protection. The drone is always going to be the most sensitive equipment in any environment.
Great, thank you very much, Greg. Mike, I'll ask you. Jim in the audience is wondering about how cell phone signals might impact the transmitter. That he had the experience that they were trying to use a cell phone hotspot to connect a second screen sharing Wi-Fi, and it seemed to cause a problem for signal. And he's just wondering if we know anything about, what cell phones do for impacting the drone signal.
Ultimately, on this type of use case, what I'd like to do is speak with Jim off the WebEx, because I think that's going to go into a little bit of a longer conversation and perhaps some R&D with us here as well, to where we would try to set something up similar, see if we could recreate those circumstances and maybe understand a little bit more about the situation that he was in.
Okay, great. And so, Jim, I think that's an invitation. Mike sounds like he's happy to just do a brief consult with you. So please feel free to email him if you do want to dive into that. Does that sound right, Mike?
Yes, absolutely. The idea is that competing signals around you, so whether it be a Wi-Fi transmitter for like a company, corporation, Wi-Fi hotspot, different radio signals, even being close enough to an RF tower, all of that stuff can have an impact on what you've got going on. But again, there's a lot of outside factors that have to be considered as far as like, where are you physically positioned? What are you around? What were you trying to accomplish, and what were you trying to accomplish it in? We just need to understand a little bit more of that stuff as well. And then again, go into the idea of trying to recreate the circumstances, seeing if we can have the same type of situation, and then trying to figure out the solution to it. So open invitation though.
Great, thanks, Mike. We only have actually a few more questions. So one is from Ardian, who's asking about factors that can cause the signal to be lost when conducting a survey using a drone in a limited area. And obviously, I think that's sort of what the whole webinar was about, but maybe Greg, if you can sum up some of those factors that might impact the signal?
Yeah, basically the density, shape, and material of the environment. So I guess everything, right? So there's the aspect of reflectivity. There's the aspect of what shape are there any like bends behind which the drone can disappear, and I guess yeah. So watch out for what material is between you and the drone would be the only thing. Well, I guess it's difficult to summarize that into one sentence.
But just being mindful of the environment in which you're working, the materials that you're working in, all those different factors need to be taken into account. And also what I've heard from both you and Mike is just to be cautious and assume that you need to be exploratory at first, that your signal may not extend nearly as far as you thought it would when you start testing. And I mean, that seems to be a lot of the takeaways from today.
That's absolutely correct, guys.
Excellent, thanks. And one last question, Jeffrey's asking, so that I'm not sure what the context is, and this may have been pasted from a larger question, but the question Jeffrey has is, how about using analog instead of digital? And I'll let Mike, if you can take that one.
Zach, if you wouldn't mind, could you say it again? I just chopped up on mine.
The question was, how about using analog instead of digital?
Oh, oh, that's a great, that is going to introduce, I think, more of a delay into what, I think that's going to actually increase the exact thing that you want to avoid, which is going to be a delay between the transmission, whether it be, it's going to be video. There's going to be some that we're going to have to discuss on that a little bit more. Again, I think unique circumstances come into where some older techniques or older technologies can be beneficial, but I don't think at this time that it's going to be possible. I don't believe Flyability has anything set up to be anything with that right now.
Got it. Okay, that's helpful. And Greg, do you have anything to add on the analog versus digital question?
Yeah, like from my experience, analog, typically it's difficult to achieve higher resolution. So the kind of HD stream that you get on Ilias 2 wouldn't be possible. Like you get some advantages where the signal starts to break up earlier, so you can see it coming. But yeah, that means you have to live with a bunch of static, until it does finally cut out. Also, it tends to have more issues with multipathing. So in a reflective confined space, it wouldn't necessarily be better, to my experience.
Got it. Okay, excellent. Oh, hey Jim, I'm not sure if you can still see the slides, but Mike's email was the first email that appears on the slide that's showing right now. I can, okay, perfect. Gotcha, you're good. We got a question from Santi Pap. Did you separate signal frequency between controller and video for preventing signal jam? Mike, I'll shoot that one over to you.
I'm actually going to have to refer that one over to Gregory, if that's okay, Zach.
Okay.
Right. So as far as I know, the signal uses several bands, so it hops between frequencies. If it notices, for example, another drone or another equipment using one side of the spectrum, it'll move to where it sees less interference. But by default, the signal, so for controlling the drone, that's an uplink. And the signal coming back from the drone is the downlink, which contains the video. So as far as I know, these are separated signals anyways, because they're moving in different directions.
Got it. Okay. Thanks so much, Greg. And we just have one more question, and this was asked specifically of Greg. This will be the last question for today. And I want to say thanks to everyone who's hung out with us a little bit late. The question for you, Greg, is what solutions are available to share video remotely or with another person on site, i.e., standing next to the pilot? This person's wondering about the second tablet option, team viewer option, extra TV set option. Can you speak to any of that, Greg?
Yeah, so basically, if you want to share the video locally, you can either do that with by streaming the video to another tablet. So that's a built-in option into our cockpit app, which is used to fly the drone. Alternatively, you could use the HDMI output plug of the transmitter to stream that to either via cable or via transmitter to a nearby television. Or you could use a TeamViewer app running on a tablet that captures your screen and streams it to anywhere in the world over the internet.
Okay, excellent. And we had a follow-up. Sorry, go ahead, Mike.
I was actually going to say, and I apologize, the other way of doing it would be the Copilot, having a secondary Copilot controller with a Copilot tablet. That's going to have the same video feed as what the pilot does as well.
Right.
Excellent. And we had a follow-up related question from Patrick, who was wondering if that's possible, which clearly it is. You guys just addressed that. How far away could that signal go?
Part of
I
that's
guess
where you're at.
Sorry, go ahead.
No, so I apologize, Greg. I was just say part of that's dictated by where you're at. So in relation to the other person, are you standing 10 feet away from them, open line of sight? Are you standing 10 feet away from them with a concrete wall in between you? Different things like that. That's honestly one of the hardest things we have an issue with when we get asked the question of, well, how far can we go, or how far is the signal going to broadcast? That's completely dependent on a lot of outside factors, like completely dependent on it. So it's very tough to answer that idea. But again, if you're relative to each other, I would say the idea would be about 30 feet. That's, at least to me, that's the comfort area I would go with, and that's open line of sight. But if I had something in between us, that signal strength is going to be cut down pretty dramatically.
Got it. Excellent. Thanks, Mike. Those are all the questions for today. I just want to say thank you so much to everyone who attended and who hung in there for these extra 7 minutes. Sorry for going over, but we really did want to make sure we answered all the questions we could. Thank you very much to Mike and Greg for presenting. We really appreciate you sharing your expertise. And as I said at the beginning of this webinar, let's see this as the beginning of a conversation. So if you have more questions, if you want to learn more, if you feel like you want to do a training, please don't hesitate to use the contact information that shows on this slide. And again, we'll be sending out this recording via email over the next 24 hours. And we have all those other webinars that are available on demand on our website. So if you want to learn more, please dive in on the Flyability website. There's a ton of other content about indoor drones. So guys, thanks again for presenting. You did a great job.
No, I appreciate you running it, Zach. Awesome job.
Okay, thanks guys. That's it for today. We're going to sign off. Take care, everyone.